Good day, students. These are the ma1026 solution videos. Today we're going to look at some solutions to page 124, number 3, practice 1. It's in chapter 5 of book 2. And it's asking us to evaluate without using a calculator, but we'll do some examples by calculator as well. Without using a calculator, these various logs you see on your screen. So what does it mean to evaluate a log? Well, let's quickly review again what a log is. A log or a logarithm is basically just another way to write an exponential equation. I know if I had 2 to the power of 3 equals 8, which is exponential form of an equation, right? Because it has an exponent. Then we know that the 2 is called the base, right? The 3 we call the exponent, and for lack of a better term I call that the value, or v. And when we switch that to logarithmic form, we isolate the exponent. So it's log, the base comes down as a subscript, so log of 8 base 2 is equal to 3. Okay, so we did this in the last video, learning how to switch from log form to exponential form and back and forth. But in this video we're asked to look at evaluating logs. Now, so if I look at the very first one here, it's saying log base 2 of 64, or you can say log 64 base 2. So if I look at this one, how do I evaluate that log? What does it mean to evaluate a log? What does the word evaluate mean? Evaluate means find a number or value, okay, that this is equal to. So if I'm asked to evaluate this, I'm asked to find a numerical answer, a number. Now, what does that mean for this particular one? Well, let's get rid of that. Log base 2 of 64. Well, you're asked to find, what you're actually finding is the exponent, because this will equal the exponent. We know that, right, when it's in log form. So in other words, if I let it equal something, so let's let it equal a variable. The most common one to use is x, or e for exponent. I'll use e in this case. Now let's switch that from log form to exponential. Okay, so we'll come out of log form and let's switch it to exponential. We did this in the last video, so you should follow that if you looked at the last video. So the base is 2. We're going to raise it to the power of the exponent, which we don't know. It's e, equals the value of this exponential form, which is 64. So when you evaluate a log, what are you finding? You're finding the exponent, right? The exponent of the base given. So 2 to what exponent gives you 64? Now you can do it long way. You could say, well, I know 2 squared is 4. If I multiply that by 2 again, it'd be 2 4s are 8. 2 to the power of 4 would be 16. 2 to the power of 5, 16 times 2, 32. 2 to the power of 6 is 64. So the answer would be 6. So you could do a longhand like that on a piece of scrap paper, or whatever way you want to find it. So the answer here, 2 to the e, we know 64 is 2 to the 6. Therefore, e must be 6, right? So the answer to this one, if we want to write it properly up here, okay, we say the log base 2 of 64 equals 6. Okay, now the very next one is asking you log base 4 of 64. Okay, or log 64 base 4. So what is the value of the exponent? So in other words, 4 raised to what power is equal to 64? Okay, so all you need to do anytime there's no variable present in a log one, just let it equal a variable, and just say, of course, we're letting it equal e, and switch from log form to exponential. And again, 4 raised to what power is 64? Well, you know 4 squared is 16. Multiply that by 4 again, you get 64. So our answer will be 3. 4 to the power of 3 is 64. Right? So we know, now some people will skip the next step and just write e equals 3 and you're done, right? Or if you want, you can rewrite 64 as a power of 4 as well, so the bases are the same on both sides. Okay, so you would write 4 to the e, whoops, that's e, 4 to the e equals 4 to the power of 3, therefore the exponent must be 3. And so your final answer for this particular one is what? 4 to the power of 4 is log of 64 base 4 is 3. Now the next one. So some people get very intuitive about this and don't have to work out any steps. They know now that if you're evaluating a log, you're looking for the exponent. So in other words, 8 raised to what power is 64? And some people just write down, okay, the answer is 2. Done. Finished. Some people need to look at it, expand it further. So they say, well, 8 raised to what power, what exponent is equal to 64? So 8 raised to what power is 8? 64 is 8 squared. And again, this is more formal step-by-step routine, but if you want to understand, just do it, okay, quickly and intuitively like that. Just write down the answer. Now look at J. It's a little bit different. We got a fraction. So we're saying 2 raised to what power is 1 over 16, right? 2 raised to what power? So when I switch this to exponential form, if I let it equal e and switch it, 2 to the power of e equals 1 over 16. Now if you remember anything about exponents from previous courses, you know that when you get into fractions 1 over, it usually means a negative exponent. And I'll just do an illustration here with the number 2. We know that, for example, 2 to the 1 is equal to 2. We know that, therefore, and we know 2 to the negative 1 is equal to a half. We know that 2 squared is equal to 4. 2 to the negative 2 is equal to 1 over 2 squared, or 1 over 4. So you can see these pattern building here. If 2 cubed is equal to 8, then 2 to the negative 3 is 1 over 8. 2 to the 4 is 16. Then 2 to the negative 4 is 1 over 16. Okay? Now if I did one more, let's say I did 2 to the 10 is 1024. That's a kilobit of information. Then, that's right, 2 to the negative 10 would be what? 1 over 1024. Okay? So there's several ways you can do this. If you understand that, now you know the answer here to our question. You know 2 to the power of 4 is 16, and 2 to the power of negative 4 must be 1 over 16. So the answer here is negative 4. That's one way you can do it. Or you can do it more formally. You can do it step by step by saying, well, 16 is 1 over, I'll change that to a power of 2, so I have same bases on both sides. And I'll change that to 2 to the negative 4. Therefore, e equals negative 4. You can see it probably that way. But the answer to J is negative 4. Now again, this one is asking us, well, 6 raised to what power is equal to 1? Now when is the only time we get 1 when we're raising something to a power? Yeah, it's 0, exactly. 10 to the 0 is 1. X to the 0 is 1. 15x all in brackets to the 0 is 1. Anything raised to the power of 0 is 1. 2 to the 0 is 1. And so on. Right? So we know that in order to get 1, 6 must be raised to the power of 0. Alright? So the answer to K is the exponent here must be 0. And the last one in this series, again, we have a base that's a half. So 1/2 raised to what power? And again, I'll let it equal e. 1/2 raised to an exponent e is equal to 2. Now how is that so? How do we make our bases the same? Remember what half though is. Usually 1 over something means a negative exponent. Right? 1 over something means a negative exponent. So in this case, we know 2 to the 1 is equal to, right? That's the same as 2. But 1/2 is what? Therefore 1/2 must be 2 to the negative 1. Right? and that pattern we tried to build a few seconds ago. So hopefully you understand that. Therefore, this is the same as 2 to the negative 1 times the e that's already there. So 2 to the negative e equals 2. Now what's understood to be the exponent right here? It's 1, isn't it? Right? It's understood to be 1. Therefore, let's write that in. Now if the bases are the same, it makes sense then. Therefore, negative e must equal 1, or e must equal negative 1. That's a little bit more confusing, I know. However, the calculator can do these for you. Now, I have an older version of the TI-84 here, so I have to do the log button but switch out of log base 10. So the way I would write, for example, let's pick one. Let's pick E. Let's pick this one to do, okay, on the calculator. Now if I was doing that on the calculator, now some of the more modern versions of this, updates of the software, does have a log base B button, and you can just put 4 in as a base and 64 and press the button. However, I think in this version I have to do it the long way, which switch it to base 10. So log base 64 divided by log 4 is the same answer. That should give us 3. In other words, I'm using this fact right here. Okay, the log base B of a value, if you want to switch it to base 10, which is the button on your calculator, is log base 10 of the value over log base 10 of the base. However, we don't need to put the 10 in. It's log value over log base, right? So what I'm doing is I'm switching it. Now the newer versions calculators, you don't have to do that. And let's check K. So log base 6 of 1 would be the log of 1 divided by the log of 6, and that should equal 0. Look at that. And we'll do L as well. So log of 2 divided by the log of the base, which is log of 1/2. And whoops, I got an extra 1 divided by 2. And that should equal negative 1, and it does. Now I know it says not to use your calculator here, but use your calculator to check your answers, of course. So when you're evaluating a log, what are you finding? You're finding the exponent. There's several ways you can do it. You can do it intuitively, just write down the answer. You can do it longhand like I showed you several times, or you can do it on the calculator. So that's a few examples of that on page 124.